All right, so we are going on to our second lesson on line plots. And for this one, we're going to basically learn how to make one out of our own based on some data that we're given. And this will eventually lead to us being able to use a line plot to interpret some answers that are given to us. So it's best to know how to make one before we move on to that next step. So let's go on to a warm up. So for this one, what's the greatest value in the list of data below? The data here is in form of fractions. So we have to determine what's greater. And sometimes with fractions, as we see here, it's really hard to tell when you've got a different denominator for most of these. So what we have to do is find a common denominator. The common denominator I was thinking of using is 8 because it's easy to change a 4 or a 2 into an 8. So 3/4 becomes 6/8. 1/2 becomes 4/8. And 5/8 we leave alone because it already has an 8. 3/4 we've done already. So this is a 6/8. 4/8 is we leave that alone as well. And 1/2 again becomes 4/8. So I want to know what's the greatest value. Well, now it's pretty simple. We can just look at the numerator, and we know that 6 is the greatest numerator shown here. So 3/4, or also known as 6/8, is greatest. And there's a second part here. It says, how many x's would a line plot show for this value? Well, since there's two of these, we would show two x's on a line plot, one right on top of each other, to show that there's more, this happens more than once. All right, so turn to page 557. And we're going to be going over this situation where we have some stickers and a person's measured the width of them, and we have to make a line plot based on this. So line plots are fairly simple to make if you follow a nice routine and stay organized and take your time. This is not something you can really rush through. If you do, you're going to have a one or two errors, and that's going to throw off the actual purpose of the line plot. So for this one, on this little piece of paper up here in the top right, we have all the measurements of the width of the stickers. And again, our warm up kind of helps us get in the right mind frame for this because we have all these fractions, they have different denominators. So we're going to have to convert some of these to an equivalent fraction that's going to be similar. So again, I've got 4s and 2s and 8s. So I will go back and try working with the 8s. So every time I see 1/4, I know I would have to multiply top and bottom by 2. That gives me 2/8. And I'll find every other instance where I have 1/4. And that's it. 3/4, I'd have to multiply top and bottom by 2. And that gives me 6/8. And this is 6/8. And that'll do it for that. 3/8 and 5/8 and 1/8, I leave those alone. And then I have these halves here. I've got to multiply top and bottom by 4 to get these, and that creates 4/8 for these. And the whole numbers I can leave alone, and I can just show you why in just a second. So we've got 2 1s there. So the best way to do this is we should figure out on our number line here, least to greatest. Let me put little arrows here, and we'll get to this number line in just a second. But the main thing is what you can do is take your data and just write it out least to greatest. So let's see what we have here in the top right. I've got 1/8. I've got that. In fact, let me just cross these out. 1/8. And I've got 2/2/8. And remember, you have to put both of them. You can't just put one because that is still data. I've got a 3/8 right here. Let's do 3/8. We've got 4/8. 1, 2, 3 of those. Got 4/8, 4/8, and 4/8. And I got ahead of myself and crossed off a 5/8. And let's see, I've got some 6/8. I've got 2 of those. And notice that there are no 7/8. They're just so we don't have to put anything there. And I know that a whole number of 1 is actually 8/8. So that's why I saved those for the very end. Okay, so there's all our data. And again, keeping track of what you've listed and what you're about to, and keeping things organized will help you. So now we have to figure out how long we should have our number line be. Not physically, but like what our starting number and our ending number is. I see my biggest number is 1 and my smallest number is 1/8. So I think it's pretty safe to say that we could have 0 be our starting point, and then 1 inch, the 1 for 1 inch over here. And since all of these are in eighths, I have to create 8 different sections on this number line. And I can do that by drawing 7 lines. So I've got 1, 2, 3, 4, 5, 6, 7. And now I have 8 sections here for that. So basically, this is 1/8, 2/8, 3/8, 4/8, 5/8. I think you're seeing the pattern already. 6/8 and 7/8. And I don't have to change 1 to 8/8. We just know that. The next part, now we plot our data. So literally a line plot means putting those X's. That's plotting your data. So I've got 1/8. I put an X here, and I'm just gonna put a check mark over that and show that I've done it. I've got 2 2/8. So I'll put 2 X's here. I've got 1 3/8. I'll put 1 X there. I've got 1, 2, 3, 4/8. So I go 1, 2, 3. I've got 1 5/8. So I'll put 1 X. I've got 2 6/8. I've got 1, 2. No 7/8, so I can just leave that blank. But I do have 2 1s that I have to put up here. So we plotted the data. You could tell a lot of things from a line plot. You could tell how many things were counted or weighed or whichever, in this case, measured. You could find out which had the most measurements, in this case, 4/8 or 1/2, and which had none, 7/8. And you could just see these patterns by making like a visual picture of your data. All right, so let's turn the page and look at some of these examples. So a lot of these we've already done with our example on the previous page. We did the fractions in eighths. The fractions were in eighths, fourths, and halves. The narrowest or the thinnest one was 1/8 inch. The widest was 1. That's true. The line plot started at 0 and went up to 1. The line plot showed an X for each of the 12 stickers. And the line plot will have a title and scale label. This one didn't have a title. We will get to that in a further question on the next page. In fact, right here, what we will do is put a title for this as sticker width, and the sticker width, and then like down here below it, we're going to do our width in inches. So what I'm saying is you can create a line plot and put your X's and do all that, but it's not going to help anyone if they don't know what it's representing. So make a title like this that is pretty obvious what it's about. And then below the line, you say what you're measuring in. So if it's weight, it's like kilograms or pounds or ounces. Or in as far as measurement for length, we've got inches. It could have been feet, it could have been miles, whichever. All right, so let's do next page. So look at the first model it. And why is it a good plan to go from 0 up to 1 inch for the line plot? So all the stickers measured between 1/8 inch and 1 inch. So that just makes sense. What scales used for the line plot in the second model? That's 1/8 inch scale. So every space was 1/8 inch. Why does the scale make sense for the data? Because after we did our conversions and made our equivalent fractions, all of the uh, all of the stickers were measured in eighths. Okay. The tick marks in the second model are not labeled with fractions. Do they have to be? How put a big old no. And even in our example on page 557 that we did together, I didn't have to label those tick marks. Once you understand the scale, you can just count over. But it's really up the person's preference that makes the line plot. There's no rule against it, but they do represent something. It just doesn't always have to be labeled. Number 5, complete the line plot and second model it. Include the rest of the data title above the line plot, which we did, and label the scale. So we did both of those things. And since we already did it, we're not going to go back and do it again. And this last one, how to use a line plot to organize measurement data. The X's show how the data is distributed. There we go. X's show how the data is distributed. And you can skip 7. It's on the page. We never do those anyway. All right, skipping 7. Let's try some of these out. So I'm going to cross off 9, the one below this one. The other one's really involved, and this one takes a little work, but it's worth the time. So let's start with just this last one. So Sean records the lengths in inches of several bugs he collects for a science project. Complete the line plot of the data. So instead of just your standard fractions, we are now given mixed numbers. So our measurements are going to be above 1 because a mixed number is a whole number plus a fraction. And you can see from our scale, we've got a 0, or excuse me, a 1, not a 0, and it goes from 1 to 4. And that makes sense because just glancing at these mixed numbers, I don't see anything that's below a 1 or just a single fraction. I don't see anything that goes above a 3. Like we are 3 1/4, but nothing that goes beyond 4. So this scale makes sense to us. So let's name what the line plot's going to be before we put anything on it. And since Sean is measuring the length of these bugs, let's call this line plot bug lengths. And then below the line, we talk about the scale. So basically the length, and in these parentheses, what unit are we using? And we're using the unit of inches. So far, so good. With our mixed numbers, we're looking at the denominators for the fraction parts of the mixed numbers. And I see 4s and 8s. So what I'm thinking we're going to do is just change these 4s to 8s and keep the one mixed numbers that have 8s. So 1 5/8 is fine. We're going to leave that alone. 3 1/4 is going to become 3 2/8. 1 3/4 is going to become 1 6/8. Do the same thing for this one. Do the same thing for this one because these are repeats of ones we already changed. And 1 3/4 becomes 1 6/8. And since we're dealing with 8s, we have to change all of these sections into 8s. And we do it the same way we did before by doing 7 lines. I've got 1, 2, 3, 4, 5, 6, 7. I've got 1, 2, 3, 4, 5, 6, 7. So now I have 8 parts here. And 1, 2, 3, 4, 5, 6, 7. All right. So let's go and plot our data. Let's start with 1 5/8. Let's put a check over it. So I've got 1, and I've got to count over 1, 2, 3, 4, 5. So that's 1 and 5/8. This next one is 3 and 2/8. So I find my 3, and I go over 1, 2, and my 3 and 2/8. My 1 and 3/4 is actually 1 and 6/8. So I got 1, 1, 2, 3, 4, 5, 6. Put an X over that. 2 and 7/8. So I've got 2. I've got 1, 2, 3, 4, 5, 6, 7. 1 and 3/4, which I've already done, is 1 and 6/8, is going to go right above here. I've already done 3 and 2/8, so I'm just going to put another X above that. Get rid of those. 1 and 5/8. I got 1, 2, 3, 4, 5. I got a second one of those. 2 and 3/8 is the only one I see for that. So 2, 1, 2, 3. I've got just 1. That's pretty simple. And then another 1 and 6/8, which is here. So I've got 3 X's above that 1 and 6/8 measurement. And there's our line plot for all of the measurements Sean did. We can see the total number of bugs that he measured. We can see that 1 and 6/8 had the most. And this also kind of helps you see that, maybe like this section right here, that a lot of the bugs are normally this width, and some can be really small and some can be really big, but there's almost like an average length for a bug. But again, it's once you have the data graphed, you can do whatever you want with it. So let's move on to our homework for tonight. This is going to be V10, creating line plots. And you're basically going to be given data, and then you fill in your X's, or you have your X's and have to fill in the data. So you're going to go back and forth with that. So good luck with that, and let me know if you have questions.